checked it. PA, oh, stop.
Well, I think I'm working on that over break, so.
So we've got temperature, we've got pH, CO2, oh, let's leave pH. Yeah. CO2, 2,3-DPG, 2,3-DPG, and pH, okay? We know when it goes to the right, you're going to have an increase in oxygen demand because the body's going to need more. So the curve is going to go to the right. And everything follows temperature except pH. Because pH, if it's a CO2 is high, it's acid, pH is going to go down. And here, everything goes down except pH goes up, and that shifts it to the left. Okay? Now, so the curve is sigmoidal. On the flat portion of the curve, you have very little change in saturation, but big change in PaO2. So you could have a sat of 95 and have a PaO2 of 90, and you could have a saturation of 96 and have a PaO2 of 225, and you could have a PaO2 of 600 and have a saturation of 98, 99. So very little change. We know that when our saturation is at 90, it gives us a PaO2 of 60 millimeters of mercury. We know where the curve is by looking at the P50. If the PaO2 is 27 millimeters of mercury, then we know we're at the P50. So it says at 50% saturation, your PaO2 is 27. So if I said to you your P50 is 30, then you know that the curve is shifted to the right.
Okay.
If I said to you your P50 is 20, then you know the curve is shifted to the left, okay? So you know which way the curve is going, okay? Now, when the curve shifts to the right, that's the Bohr effect, and what happens is that the hemoglobin's going to give more oxygen to the tissues. When the curve shifts to the left, that's Haldane, and it's gonna hold on, like hold. It's gonna hold on to the oxygen and only give it to the tissues that really need it, like the brain, the heart, the lungs, the kidneys, and that's those areas.
The vital ones.
The vital
Okay.
ones.
All right,
okay?
great.